Hello students, welcome once again to Dr. Saurav's classes. Yes, you have guessed it right. We were doing group theory videos, and today we are going to talk about subgroup. You remember in the previous video I showed you an example. I would like to go back there and show you once again that example. Here it is, all scribbled up, jumbled up, and left for you as it is. You can take a photograph if you want, a print screen, or you can just go back to the previous video and watch what happened. Okay, so if I'm to just give you a recap on what happened over here is I had taken a function f of x that you can see around here, f of x. Okay, where is the color? F of x, this is the function. Okay, that's not working. That's even not working. We got to get something else. We got to get some other color. Okay, where is that? YT? Yeah. Why is it not writing? Okay, I understood. Okay. Yeah, here it is. Here's the f of x function. Yeah. And then we went ahead and took another function because we found that f of x is going to give us an identity. Then we went on and found another function. Then we went on, did g of gx of that function, found another thing that the identity is coming out, and then we found the order of the element as 2, order of f is 2, order of g is 2. So we went ahead and we did the composition of f of g of x, both of them, and we found out that a new function is coming out, and we named the function p of x. And then we did p of x, and we went ahead and solved it, and we continued getting new functions, right? So we said that the order of the element of f is not finite, since we are getting a new function and we have to continue. So moving on to the next part, that is subgroup, for this video and probably a little bit more also. So let's not waste much time and let's talk about what is a subgroup. What is a subgroup, students? A non-empty set H, let's say H is a non-empty set. Okay, it has elements like say 0, 1, 2, 3 and many more. Okay, so a non-empty set H of G, of a group G. G is a group, big group, from where the small non-empty set is taken, the small non-empty set is taken. So a non-empty subset G, subset H of G is said to be a subgroup of G if H itself is a group under the same binary composition as that of G. Okay, let's rub this, it's cutting off that. Okay, so what does that mean? It means that it is called H will be called a subgroup of G when it follows the same binary operations, right? Same binary compositions are that of G. Alright, same binary composition. What was the composition of G? What were the rules of G group for anything to be a group? What were the rules? The first one was the associative property, right? A star B is equals to A star B star C is equal to A star B star C, isn't it? Then we had the identity property, right? You remember we had the identity property, A star E is equals to E star A. Then we had the inverse, INV, right? The inverse property, what is it? A star A inverse is equal to E. Alright, so and in A inverse star A is equal to E. Alright, now this is equal to A, of course, the identity. So if the if this H follows the same binary 1, 2 and 3, if this H follows the same 1, 2, 3 binary operations, if it follows the same thing, then it is called a subgroup. So there are few examples of subgroup given to us. You see the subgroup Z integer with binary operation plus is a subgroup of who? Of subgroup of rational numbers with binary operation plus, right? So let's rub that off. there you go, plus, right, which this in turn is a subgroup of real numbers with binary operation plus, where real numbers is a subgroup of complex numbers with the binary operation plus. Okay, so what can you say? Z plus is a subset of Q plus, which is a subset of R plus, which is in turn a subset of C plus. So C plus is a superset. Okay, moving on to the second one. Some more examples of subgroup will be the general linear group of order n of real numbers, and the first one is the special linear group of order n on real numbers. All right, and the next one will also be a subgroup of order n where A belongs to the m of n of R, that is the matrix, actually matrix on real numbers, where A into A transverse will give you 1. You know transpose, yeah, transpose of a matrix. I know you all know, you all are smart students. Okay, I know you all are very smart students. So there is no question of you not knowing what is A dot A transpose, right? Very simple, right? I just show you even still. Like suppose you have A, B, C, D, right? So the transpose will be equal to, so you have T, it will be A, B, C, D. Simple. The rows become columns, and that is why it's called a transpose. So it is the set of all orthogonal matrices of order n. So this is the set of all orthogonal matrices of order n. Okay, students. All right. Okay. So students, you so what does it mean? O of n is equal to A belongs to m of R of n, A into AT. Then that is a set of all orthogonal matrices, and all of you know what is an orthogonal matrix. When you have a matrix, say A, and you multiply it with its transpose and you get the answer as 1 or identity. Okay, you get the answer as identity or 1, that means that is an orthogonal matrix. Okay, and third one is what? A belongs to Mn of R, okay, of real numbers. A dot AT is equal to 1, and the determinant value of A is equal to 1 is a subgroup of order m. Similarly, the set of all unitary matrices forms a subgroup in general linear of order n of complex numbers. Okay, so that means you can see over here the Q dot or Q multiplication is a subset of R multiplication is a subset of C with the binary operation multiplication. So every time I'm not going to say binary operation multiplication, you know what it is, isn't it? So students, what did we learn on subgroups? We learned that when H is a subset of any group G and it follows the same binary operations, it follows the same binary operations here, 1, 2 and 3. If it follows the same binary operations, why is it going up? If it follows the same binary operations, okay, then it is a group, it is a subgroup of that group. And you can see there are some of the subgroup examples are already given to us. Okay students, so I don't think that this is much difficult, right? Modern algebra or this what do you call this, group theory is much difficult, right? So you just have to go through, you just have to, you know, understand what is a subgroup of what, keep some notes, memorize little bit, okay, use your brain properly in proper proportions so that you can get a grasp of this subject or of this part of mathematics. Okay, and that's it for today students. We will continue with this. I know you have seen what is in the next part, so you know the videos will be continuing and there will be more to this, so you might want to go ahead and watch so that your burdens in your exam becomes much more less. Okay, because these videos are going to be really helpful. So please take as much help as possible, because all the help that you will be needing will be always provided here at Saurabh Sir's classes. Thank you for watching, students.